So we started this lesson on Coulomb's law with revision on vectors because there are directions that are important when finding the net force. So just as a quick reminder, if we have something going left by 2 meters, up by 3 and then right by 6, well, we know that in the horizontal direction he went 6 right and 2 left. That means this is in total 4 right. So if I take this far up to here, this is 4 meters. 6 minus 2, 4 meters. And this is 3 meters north, which means this is also 3 meters. And you can see that we have an angle already. This is a little triangle that we can turn this into. You can make the triangle like this, or you can make the triangle along this way and up. Both of them will be right angle triangles, funnily enough. So you can find this angle, or you can find this angle. It doesn't matter which one you do. You just need to make sure that you know whether it's north of east, south of east, or wherever, which part of the thing you're doing. But let's stick with this. If you're doing this, we can just figure this out. This is a 3, 4, 5 triangle using Pythagoras. C squared equals a squared plus b squared. This will tell you that this is actually 5 meters. And then you can use tan inverse to find this. Of course, this is the hypotenuse, then this is the opposite, this is my adjacent, and you can do tan minus 1, this divided by this. I'm not going to go into details of that. We'll save that for another video. Okay, in fact, I've got the answers here actually. We did this in class. Here are the answers. 3 squared plus 4 squared, and in the last lesson, I did this angle with you. In this lesson, we can easily just use this angle. The rules are the same. If you use the bottom angle, we use tan, everything's the same, except for I've got 37 degrees on this side. When you solve it from the other side, you'll get whatever 90 minus 37 is, you'll get, what is that, 90 minus 37? You'll get 53 degrees. So if we do this one here, this will be 53 degrees. Okay, very nice. So part of this lesson is Coulomb's law, and we did some interactive with this. Did a little simulation, figuring out the direction of the forces, which forces are smaller. We realized that when the forces are the same, they will repel. When they're opposite, they attract. And they are equal and opposite forces, which is Newton's laws, Newton's third law. And they have opposite directions every time. Coulomb's law is going to be between two charges and the distance between them, and they will have some sort of force on each other. If this is a positive and this is a negative, they will be attracted. They will come together like this. And there will be a force pulling them together, and we can calculate that by using k, q1, q2 over r squared. This is magnitude. These lines mean magnitude, so I don't care about the minus sign here. This will be, if it's one electron or one proton, 1.6 times 10 to the minus 19 multiplied by 1.6 times 10 to the minus 19. It's the same. And I'll divide by r squared. Okay. K is Coulomb's constant, which we know is 9 times 10 to the 9. It stays the same, never changes. Sometimes it's written as 1 over 4 pi epsilon naught. And that is not so important right now, but it is going to be important later when we're talking about symmetry. But for now, we just need to recognize it for Coulomb's law. And E naught is 8.85 times 10 to the minus 12, which we will be using quite a lot in Gauss's law. But for now, we can stick with K. We can stick with k, q1, q2 over r squared, and that will help us solve our problems nice and easy, because these are all constants. So when you multiply them together, you get the same number, which is this number here. Okay, so we did some practice here. We used the formula, and what I reminded you of the prefixes that are normally used. We often use nano, and we often use micro, milli as well. Sometimes we will use kilo. A few times you'll see centi. So these are really important to know. These are the multipliers, and then this is the scientific notation of all of them. Nano minus 9, I remember that by saying nano 9, n and n. Micro will be minus 6, milli is minus 3, centi is minus 2. And then kilo will be times 10 to the power of 3. Okay, so this is important for you to use when you're doing these calculations. So this is one example that I have done already with you in class, calculating the force between this and this charge, and the distance is this much centimeters away. So we've got nano, we've got micro, and we've got centi here. So f k q1 q2 over r squared, 9 times 10 to the 9, multiplied by 10 nano, so minus 9, multiplied by 5 micro, minus 6, divided by 10.2 times 10 to the minus 2, because it's centi, squared. And then you get your answer. I've shown you how to use a calculator, so I think this might have been the example that we did use in that calculator. Okay, and some more practice examples that we have done. This is already on the PowerPoint, so you can check it out yourself. And K, Q1, Q2 over R squared, multiply them all out together, and you will get this number. Easy peasy stuff. The superposition principle is when you have a resultant force on multiple charges, because you might have 3 charges here, which means this will feel a force because of all 3. If they are positive, assuming they're both, all 3 are positive, and assuming this is positive, he'll be repelled by Q1 that way, he'll be repelled by Q2 that way, and Q3 that way. So you have to figure out the overall force and the direction that the overall force is going in. It depends on which one is the strongest. If they're equal, then you will do the calculation and add the vectors. You add the arrows from tip to tail. So this will be the first arrow, that arrow, and maybe even that arrow. Let's say, for example, the resultant will be from the start to the finish. That's how it would go. So if they're in the same direction, of course, we will add them. If they're in opposite direction, we will subtract them. If they're perpendicular, we'll use Pythagoras. And if they're at an angle, we have to do the x and y components. So if you take each vector that's going at an angle like this, we can do h cos theta and h sine theta, like this. So this is always cos, horizontal is always cos, vertical is always sine. So you add all the x's together. So for example, on this over here, we have a force like this one. So we add this x with the b's force. The b is also this x here. So you add them together. This plus this. That helps you make one big triangle, by the way. We also even have c over here. So then you add that x1 plus x2 plus x3. That gives me the total horizontal amount. Okay. And then you do the same with the y's. The y, ay, by, and cy. Add all 3 together and you get one big triangle. And this big triangle happens to be D. There you go. And then you can use Pythagoras to finish it off. So you'd use the cos and the sine for each component, and then you can use the big one. You probably won't be asked to do anything like this in your exam, but it's good to know that this, what's required, what could happen, what could come up. So we did some more examples. Again, I'm not going to go through examples with you. I'm going through the theory in this one. I don't want this video to be that long. And easy step to find which way the forces are going in. You decide in the direction of the force. You use Coulomb's law to find the force, and then you just add or subtract. So you will just add or subtract. If I have a charge here, here, and here, and let's say I'm talking about this one, and let's say he's attracted to this and to this. If he's attracted, that means he will be positive and he will be negative, or negative, positive, positive. They are being attracted. So in this case, I know that this is going to the right, this is going to the left. We will subtract. I will write subtract because of this. Okay. Did some more practice, instructional guide, a few starter questions. Did more examples with you. You can check these on the PowerPoint. And if you need me to go through them again, I can. And I think that was it. We got a bit more detailed stuff, which was this one here. And I'm going to go through this again with you in class. Easy peasy.